Hello guys, welcome back to my YouTube channel. So presenting to you the third lecture on operating system. In this lecture we would be covering about the different scheduling algorithms that include first come first served, round robin and so on. This video covers all the aspect of scheduling algorithms. Believe me or not, you will find this video very useful for your competitive exams as well as your university exams. So come on. So let's start with today's topic, which is of CPU scheduling. Now, what does CPU scheduling actually means? For example, here we have a CPU that is currently assigned to process P1. But now the process P1 is requesting for certain resource, that could be an input output resource or anything. So in that case, if the process has to access the resource, in the ideal condition, the CPU have to be idle. So in order to prevent that thing, the CPU is gonna preempt this process P1, store the content into the PCB in stack, and it would be executing the P2 process. So it would give the resources to P2 and it would execute the P2 process. So in this case, the CPU is not getting idle. This is the main philosophy behind the CPU scheduling, where the concern is that the CPU should not be idle anytime. The advantages include the system gets more efficient and the system gets faster because we are going to execute more number of processes instead of executing a single process. So the idea behind the CPU scheduling is that CPU should never be idle and the schedulers should be ready to launch any process at the time when CPU is idle in the case. So what does the word schedulers means? So we all know that there is a ready queue where the process that needs to be executed are stored, and there is a running queue where the process which have the CPU is running. So this job of the schedulers is to get the process in the ready queue be ready so as it can get executed and run. So there are concept of the process scheduling, which means that if one process is executed and it needs a resource, so CPU is going to preempt that process and it's going to make the other process run. So it's what one process is in and the other process is out. So in the process scheduling, we use the schedulers in order to schedule the task. So these are long-term schedulers, short-term. Okay, so first one scheduler is a long-term scheduler. It's gonna decide which type of process needs to be there in the ready queue. For example, it have to choose a mix of CPU bound and IO bound processes so that CPU should not be idle or there should not be the load on the CPU. So CPU bound processes which needs more execution of CPU, and IO bound which means they need more resources. And then we have the short term schedulers where we have to choose the process from the ready queue that should be executed the next when CPU is idle. And there is a term called dispatcher. So the process that's selected by the schedulers are given the CPU by the dispatchers. And then we have the medium term schedulers that are used for swapping in and out of the processes. And then afterwards, if we discuss broadly, the scheduling is of two types. First one is preemptive scheduling and second is non-preemptive. Preemptive means if we can switch between different processes at a time. For example, if I am executing P1 and I need P2, so P1 have to access any resources. So P2 could be executed in place of P1 so that CPU should not get idle. And then we have the non-preemptive, which means that if I am executing P1 and it needs 5 seconds of time and I am starting at 0, so whatever there is a consequences, the P1 should be executed till it gets completed. After that only CPU can switch to the next process. So while discussing about the process execution, so we need to know about the terminologies. The first one is the arrival time, that is simply the time at which a process arrived in the ready queue. Then we have the completion time, the total time taken by a process to complete its execution. We include every phase, whether it's a scheduling algorithm, whether it's given a priority, whether it's exempted, whether it's preemptive. Everything is included, and the total time it gets to complete one process is the completion time. Burst time is the minimum time that's needed for a process to complete. For example, if there is a process P1 and it needs 10 units of time to complete, so that 10 units of time is the burst time. However, if due to preemption it gets completed on the 20 units of time, so that 20 units of time is the completion time. Then we have the turnaround time, which is simply the completion time minus the arrival time. And then we have the waiting time. Waiting time is how much time the been spent by a process in the ready queue, that's a waiting time. So that's a turnaround time minus the burst time. And then last we have the response time, which means that whenever the CPU was first allocated to a process minus the arrival time. So starting with the first algorithm, which is first come first serve, that's like pretty much obvious. That means the process which is first in the queue would be given the CPU first. So the process which comes first should be served first. That's the main phenomena and the idea behind this scheduling algorithm. So there are certain points. One is it's simplest of all the algorithms that we are going to use in CPU scheduling, and then it means that if one process gets CPU, it have to get the CPU until it gets completed. So once it get completed, then only the CPU can be allocated to the next resource. Until that time, the process will only run. Once it get completed, we can switch the process. Then it is based on first in first out like selection. For example, we have different processes, for example P1, P2, P3. So how the process is selected, so that's first come first serve. So first in first out, the process that comes first in the ready queue would be given the CPU first. And then it is non-preemptive. This needs to be noted. We cannot preempt the task because it is first come first serve. So once which comes first would be served first, and the disadvantage is that it have high waiting time. So we can get more knowledge of it by solving this numerical. Here we have, draw the Gantt chart and calculate the average waiting time for the first come first served with the following details. Gantt chart is a representation of the execution phase of any process. So we are going to discuss about how the process is going to execute, how much time basically it's going to take. So Gantt chart is about the timestamp, so how much timing the process is going to take. And we already discussed the burst time, that's how much time it needs to complete. Completion time is that at what time it gets completed. Turnaround time is completion time minus arrival time, and waiting time is turnaround time minus burst time. So here, because there is no arrival time, so we have to assume that arrival time in this question is given 0. So everyone is arriving at time 0. Because it is first come first serve, so we are assuming that P1 is first in the queue, then P2, then P3, and then P4. It is gonna move like this way. So if I'm drawing the Gantt chart, this is the 0th interval. At 0, what's in the queue? We have the P1. P1 would be executed for 21 time units, and then afterwards, once it get completed, we are going to switch to P2, and then P2 needs 3 units of time, so 3 added, so it would be 24. The next one is P3, 6 added, 30. The next one is P4, 2 added, 32. So we are getting that the P4 is completed at 32 unit of time, P3 completed at 30, and P2 completed at 24, and P1 21 respectively. So we are writing the completion times over here. So the completion time for P1 is 21, for P2 is 24, P3 30, and P4 32. And then we have the turnaround time in the queue. So what is turnaround time? Completion time minus arrival time, because there is no arrival time, so we are assuming it's 0. So turnaround time would also be same. And then we have the waiting time. So waiting time means turnaround time minus burst time. So this is turnaround, this is burst time, subtracted 0. Now what does waiting time means? How much time it spends in the ready queue. So now you can look in the figure. At the 0th interval, this process arrived, and when it arrived, it gets CPU, it gets executed, so it doesn't wait it for any moment. But we are also assuming that these processes also arrived at 0th interval, but these are getting the CPU at 21. So there is a waiting time of 21. So now I subtract this, so you're going to get 21. Subtract this, you're going to get 24, and this would be 30. So this is the waiting time for the process in the queue. And then we have to calculate the average waiting time. So that would be 21 plus 24 plus 30 divided by total number of processes were so here 0 is also added because of the P1. So we have the sum as 5, 3, 4, 5, 6, 75 divided by 4. So we have the 18.75 units of time. That is the average waiting time in the first come first served algorithm. So the next one we have is a shortest job first. From the name, it's very clear that the process with the shortest burst time is executed first. So the process with smallest burst time is executed first, and this may or may not be preemptive. We are going to look at different examples, like one example of each of these. And then we have the average waiting time is reduced. This is the advantage, and this is the question that's asked many times, that the shortest job first has a minimum of all the algorithms waiting time. So waiting time is reduced to a large extent in shortest job first. And then the only problem is that it may cause starvation, because in shortest job first, the one which have the shortest time gets executed. So the processes which needs larger burst time can starve, they may not get the resource. So let's solve one question related to this. Draw the Gantt chart, calculate average waiting time for non-preemptive shortest job first. Now in this case, we are given the arrival time and we are given the burst time. We have the non-preemptive. Non-preemptive means we cannot preempt the task once it gets started. So with starting, so on the interval p, on the interval of 0th time, we only have one process in the queue, that's a P1. So it would be executed first. Because this is non-preemptive, it would be completed. It needs 7 units of time, so it get completed at 7. So now this P1 is not in the queue. And then afterwards, we reach the 7. By 7, 2, 4, 5. So all these three processes have arrived. Now the shortest burst time is with P3. So P3 would be executed for next. It needs only 1 unit of time, so it would be completed by 8. And then afterwards, again the P2 and P4 were there. So now they both have equal units of time. So we have to choose P2 because it arrived first. So we are using P2. It needs 4 units of time, completed by 12. And then we have P4, again 4 units of time, completed by 16. So we may write the completion time. P1 is completed on 7, P2 is completed on 12, P3 8, and P4 16, right? And then we have turnaround time, which is again the completion time minus arrival time. So completion time is this, arrival is this. So this is 7, 10, 4, then 11. And then we have the waiting time. Waiting time is turnaround time minus burst time. So this is turnaround time, this is burst time, 0. So P1 waited for 0 seconds because it was the first to get executed. Then 10 minus 4, 6, 4 minus 1, 3, 11 minus 4, with the 7. And now we have to calculate the average waiting time, would be 0 plus 6 plus 3 plus 7 divided by 4, 10, 16, 16 divided by 4, it is 4 units of time is the average waiting time, and it gets reduced to a large extent. I think all of you are getting these things. Now we have the second question, that's a part 2 of the shortest job first algorithm. Here we are discussing about the preemptive shortest job first. Preemptive in the sense we can exempt a process. So we would look in the examples. For example, we have the 4 processes given with the arrival time 0, 2, 4, 5 and burst time respectively. We have to calculate these like waiting time, completion time and turnaround time. So starting with the 0th interval, we only have process P1. So we have the process P1. It would be executed till process P2, till 2 units of time. So it gets executed for 2 units of time. So we get 5. 2 is already executed. Now at 2, we have the process with shortest time. So it would be executed. Now P2 would be executed for 2 seconds. For 2 seconds, because at the P4 we have the process with only 1 unit of burst time, so there P3 would be executed and completed. Okay, now this process is completed, and next by 5 we have the P4 with 4, but we have the P2 that's only having burst of 2 seconds, so P2 would be executed again next with 7. Then we have 5 and 4, this is the smaller, so P4 would be executed for 4 units of time, that would be 11. And now this is completed, the only thing left is P1. It would be executed for 5 units of time, which is 16. So we have total completion time for P1 to be 16. Now let's check completion time for P1. P1 gets completed here, it's 16. Then we have for P2 gets completed here, it's 7. P3 completed here 5, P4 completed at 11. Turnaround time, which is again completion time minus arrival time. This is completion, this is arrival. 16 minus 0, 16. 7 minus 2, 5. 5 minus 4, 1. 11 minus 5, 6. Now waiting time, turnaround time minus burst time. This is turnaround, this is burst time. So 16 minus 7. We are not considering 5. We are considering 7. So we have here 9. 16 minus 7. We have 5 minus 4, 1. 1 minus 1, 0. 6 minus 4, 2. So here is a 0. Why it's 0? Because P3 arrived at 4. P3 executed at 4. So its waiting time is 0. And you have to calculate the average waiting time. That would be 9 plus 1 plus 0 plus 2 divided by 4. 12 by 4. That would be 3 units of time. That's very simple. So shortest job first is very important. You have to know about both types of shortest job first. It could be preemptive, it could be non-preemptive. We have discussed both. The next is priority scheduling, one of the most important scheduling algorithms. Priority means that something has higher acceptance or priority than other, means that the one with higher priority would be executed first, would be given more respect, or would be given CPU at first. So here is that it is always of preemptive type, because once we have the priority, so we are going to preempt the task and move to the other task, and it works on basis of the priority number. Smaller the number, higher the priority. For example, we have 3 processes which are given the priority 3, 2, 1. So the process P3 which have the number 1 is of highest priority. So smaller the number, higher is the priority. And if we have the same priority, we have to focus on first come first serve. So the process which was earlier in the ready queue would be given the execution or the CPU. And the problem is it may cause the starvation. I'll tell you how it may cause the starvation. We'll look at this question and we'll answer the doubts. So we have to determine the average waiting time and turnaround time for the priority scheduling algorithm. Consider the process arrived at time 0 in order P1, P2, P3, P4 and P5. So now we are given the order. It means that P1 was first, P2 was second, and so on. So it is giving us a sequence of how the process arrived in the ready queue. So now let's make the Gantt chart. So at 0, because arrival time is again not given, so we are assuming to be 0. At 0, highest priority was P2. So P2 would be started, because we are given that we are assuming that everyone arrival time is 0 because it's not given. So P2 would start executing. It's of highest priority. I am completing it and it gets completed at 1. This is done. Then we have to find the second highest priority, which is P5. So P5 would be executed for 5 minutes of time. It would be completed and done. Then we have 3, but now 3 priority is given to 2 processes P1 and P3, but we have already noted that P1 was first in the queue, so P1 would be given the execution. Here I am executing P1. It would be executed for 10 seconds. I'll getting 16, and then we would move on to this P3 that is being executed for 2 units of time. So we would be given 18, and the last priority is left for P4 that would be executed for 1 unit of time, and hence it gets completed. So now completion time for P1 gets completed at 16, P2 gets completed at 1, P3 gets completed at 18, then P4 at 19 and P5 at 6. Turnaround time, subtract these. So arrival, because arrival was 0, this would be same, and this is 6. And then we have waiting time, subtract these two. 16 minus 10, 6, 1 minus 1, 0, 18 minus 2, 16, 19 minus 1, 18, and then we have 6 minus 5, 1. So we have to calculate the average waiting time. 6 plus 0 plus 16 plus 18 plus 1. Divided by 1, 2, 3, 4, 5. 5 processes in queue. So this is 22, 9, 10, 11. So we have 41 by 5, 5 8 the 40 and 5 to the 10. So this is 8.2 is the average waiting time in the priority queue. So priority scheduling, sorry. So this is very easy, but very important concept of the scheduling algorithms. You all must know this, and I hope everyone is clear with the priority scheduling. So the most and highly important and recommended algorithm is round robin. This is the very best sort of algorithm because it covers all the aspect of the process to run. It doesn't cause starvation. It maintains that the no process gets starved of the CPU execution. So it focuses on all the concepts. So it's like each process is cyclically assigned a fixed time slot. Here we are assuming that the queue is of circular type. We have different processes loaded into the queue, but after a fixed time interval, these processes would be loaded back at the tail of the queue, and the CPU would be given in a sort of cyclicity. And then it is a preemptive version of first come first served. Here we have the concept of time quantum, and that is fixed for all the processes. We are getting a fixed time interval, for example 2 seconds, and that would be given to every process to run. And after the 2 seconds, the CPU would switch on the process to the next process. And the advantage is it's starvation free. So let's understand with the question. Determine the average turnaround time for the round robin algorithm with time quantum of 5 milliseconds. No arrival time given, so assume it to be 0. Starting it with the process P1. So we have the time quantum of 5, so every process would be executed for 5. So it has a burst time of 6, but it would be executed for 5, and then it would be switched to P2. Before telling this, I have to tell you we are maintaining a ready queue over here. For example, we have P1, P2, P3 and P4. Okay, so once we are making the running queue, so now P2 would be executed for 5 seconds, but it only needs 3 units of time, so it would be completed by 8. So this is out of the queue. And then we have the P3 that also needs only 1 unit of time, so it would also be completed. Then we have P4. P4 would take 5, it would go to 14. Here still 2 are left because we have only the time quantum of 5, but it needs 7, so 2 units are still left. And then again, so now after P4, the process P1 would again be executed. So this goes back into the ready queue. So P1 is again executed for 5, so it needs 5, and we also have 5 for 19, and last only P4 is left, so we have 21. So completion time for P1 is 19, P2 is 8, P3 is 9, and P4 is 21. Turnaround time again same because of arrival time is same. And then we have the waiting time. Waiting time would be turnaround time minus we have response time here. Waiting time could not be there because CPU is switching between different tasks. So response time is that whenever they first got the CPU minus arrival time. So when did the process P1 first get the CPU? It's 0. P2 get first CPU 5, P3 8, and P4 9. So what's the average? 0 plus 5 plus 8 plus 9. 7 divided by 4. 17. We have 22 divided by 4. 4 5 the 20. We have 5.5 is the average response time. Last topics of queuing are multiple queuing. Multiple means there are more than one type of queue. So if we are using more than one type of algorithm, that means multiple queuing. So here the ready queue is divided into different classes where each class may have their own scheduling algorithm. That's it for the multiple queuing. And for the multi-level feedback queue, it is based on multiple queuing. The only difference is that we get more flexibility in the multi-level queuing. We can move between different queues, we can set on the priority, we can switch on the process between different classes or the different queuing algorithms. So that was all for the CPU scheduling algorithms. I hope everyone is clear with all sort of algorithms. So for more videos like this, do subscribe my channel. Click the bell icon to get notifications, and please like, share and subscribe and share to your friends too. So bye, and meet you in the next video on operating system.